last day, if you remember, right, we started to look at converting a trig like this, A cos theta plus B sine theta, into the form R sine theta plus alpha. And we also took a look at something called general solution. So we learned to find the general solution for sine, for cos, and for tan. That's how we stopped last day, right? What's up? It don't matter, it's commutative because it's like saying B sine theta plus A cos theta. So it'll work. It'll work when it's the plus sign, right? Right. So yeah. So we looked at converting them into this form. I showed you how to find R and how to find alpha. Right? We also said that the maximum value is R and the minimum value is minus R. So that's what we did last week. We did questions, and I showed you, I told you today, we're going to try the past paper version of it. All right? So let's take a look at the past paper version of it. We'll talk it through together, and then we'll start it, right? All right, so watch this here. They gave us f of theta, and they gave us that version of it, and they told us what form to put it in, right? You'll recognize plenty of the recent years, they're telling us what form to put it in, right? After you put it in the form, they want the maximum value of that. You should have an idea. And then they want the minimum value of this. Not too difficult. Try it, let me see. F of theta is equal to 3 sine theta, that, and they told you the form, right? So it means that R is the square root of 3 squared plus 4 squared, which is 5. When you compare 3 cos theta minus 4 sine theta, when you compare it to R cos theta cos alpha, you'll end up with R cos alpha being equal to 3. So you could easily find alpha. Alpha will be cos inverse 3 over 5. All right, so your final answer is R cos theta plus, how much you all got with 3 and 5? 0.927. Nice. So that is your f of theta. So what's the maximum value? The max value is 5, right? I know they didn't ask, but the minimum value is minus 5. There's no other value, right? 5 or minus 5 at the range, right? How do we find the minimum value? Well, what we could do is we could take 5, see what we get, and put in minus 5 and see what you get, which is smaller. That's it. So what's the minimum value of this? 130. Right? Just put both of them. You have to, sometimes you have to put both of them just to make sure. Yeah, working in radians. Watch here. See how they put pi on 2? Means you're working in radians. Okay, let's try one more like this before I give you some more rules, right? So we see this is the easiest math that you can get, right? Let's take your time with the smallest non-negative angle part. All right, so first thing first, they told us that f of theta is equal to sine theta plus cos theta, right? We want to get it in the form R sine theta plus alpha. So the first thing we need to get is R. We know R is 1 squared plus 1 squared, which is the square root of 2 in this case. And then we're going to take sine theta plus cos theta and make it equal to the expansion of this, which is 5 sine theta cos alpha plus R sine alpha cos theta. When we compare, we'll observe that R cos alpha is equal to 1. So it means that alpha is cos inverse 1 over root 2. That's a standard value. So we should recognize that alpha is equal to pi on 4. So therefore, f of theta is really R, which is root 2 sine theta plus pi on 4. right? That's the answer for part 1. In part 2 now, what they ask for, they ask you to find the maximum value of f. So the maximum value of f is positive r, which is root 2. Right, now here's what. They want the smallest non-negative value of theta, which will make this happen. So they basically want us to solve for theta. So all we have to do is to solve root 2 sine theta plus pi on 4 is equal to root 2. Of course, it's much easier than that. Huh? Well, when sine theta is 1, it's maximum, right? That occurs when theta is what value? Pi on 2, right? So you can easily do it like that. But in case you're not seeing that, carry across the root 2, that will cancel. You'll get sine theta plus pi on 4 is 1. Carry across the sine, and you'll get sine inverse 1. Sine inverse 1 is pi on 2. So you'll get theta, the one is smallest, right? So it's pi on 2, and then you find the value the next cycle, but the one is smallest. So theta will be pi on 2 minus pi on 4, and we got the answer to be pi on 4. The part underneath there is pi on 4. That's the answer, pi on 4. But if you want, you don't have to do all that. Huh? Watch this, we're writing here in blue. Remember, for sine theta, its maximum value is 1, right? And the maximum value for theta will be pi on 2. So it means that this here is maximum when this is equal to pi on 2. Right? So you don't really have to go through all of that later on, but it's a good habit to follow. A good thing to practice is to do this here. Okay? So that's the answer there. Pi on 4. The part that's missing there is pi on 4. So the last thing that we need to do, technically the last thing in trigs, but the last set of formulas that we need to learn are the factor formulae. Right? Factor formulae is where we end up with formulas that will give us answers for sine A plus and minus sine B, cos A plus and minus cos B. I don't think these is common sheets, so you have to learn these off, right? So you see, normally we had sine A plus B, right? Which is sine A cos B, so on and so on, right? But some people just expand this wrong and say this. These two are not the same. So technically, we don't have a formula for this as yet. Okay? Do not expand and get at it. That's wrong, right? We are going to develop a formula. I'll do one for you, and then I'll give you the others, right? You don't have to learn the proof. All you have to do is learn all the rules. So let's recall a few things, right? Let's say we have sine x plus y. Sine x plus y is sine x cos y plus sine y cos x. And sine x minus y is equal to sine x cos y minus sine y cos x. Suppose we want to add these two now. Suppose we want to add sine x plus y and sine x minus y. When you add this, you will end up with 2 sine x cos y. When you add this, you'll get 0, right? Right, so here we could do, remember, I want to get a formula for sine A plus B. So if I let A equal to x plus y and B equal to x minus y, then watch this here, right? I'm doing it right here. Suppose I add A and B. I'll get 2x, and if I add A and B, the y's will cancel, and I'll get 2x. So it means that x is equal to A plus B all over 2. Suppose I say A minus B. What will I get? 2y. And I could say that y is A minus B on 2. All right, so let's make a substitution now. Let's substitute for A here. Let's substitute for B here. Let's substitute for x here. Let's substitute for y here. All right. So when we make a substitution, we're going to get a new formula. we're going to get sine A plus sine B is equal to 2 sine, I'm going to replace x. X is A plus B on 2, cos y, A minus B on 2. That's it. You don't really have to learn the proof, but you have to learn those new identities, sine A plus sine B. Okay? If you had a guess, what would be sine A minus sine B? If you subtract them instead, this will cancel it. If you subtract in the middle here instead, these two will cancel and you'll be left with 2 sine y cos x. So your overall formula will now look like this. 2 sine A minus B on 2 cos A plus B on 2. Right? So just switch around where x and y is. All right? Copy it down. Take the rules of cos one time, right? Cos A plus cos B, and take the rules for cos A minus cos B. Notice cos A minus B has a negative sign in front, right? Let's take a quick example. Suppose I said cos 3x plus cos 2x. Are we doing that? This is the A, this is the B. And that's it. Plug it in the formula with the cos A plus B and you're done. So that'll be cos 3x plus 2x all over 2 cos 3x minus 2x over 2. So you're ending up with 2 cos 5x on 2 cos x on 2. Right? Please don't try and factor out the half one thing. Huh? You can't do that for these functions, right? Suppose I had a product something like this now. Any idea how to express it as a sum of trigs? So why to write it in a form like this? Huh? So what we'll have to do is check and see which of the rules have sine and sine, right? The only rule that have sine and sine is cos A minus cos B. So we're going to have to find a way to compare it, right? We can compare this to minus 2 sine A plus B over 2 sine A plus B over 2. So therefore, this here has to be equal to this, and this here has to be equal to this. So sine 9x, sine 3x, right? I want to write it as a sum of trigs. And we're going to compare this to 2 sine A plus B on 2 sine A minus B on 2. The trick is for us to figure out what, we could always get rid of this minus 2, right? The trick now is for us to figure out what is A and B. So here's what we know. By comparing, we know that A plus B over 2 is 9x. So it means that A plus B is 18x. And we also know that A minus B on 2 is 3x. So A minus B is 6x. If we add here, let's add both of them. We'll get A plus A is 2A, B minus B is 0, 18x plus 6x is 24x. So it means that A is equal to 12x, right? And it also means that B is equal to 6x, right? Remember, this is equal to cos A minus cos B. I'm moving across the minus 2, right? So now we could say minus a half cos A, which is 12x, minus cos B, which is 6x. So I compare this to minus a half cos A plus B, and I equate the 9x with this, and I equate the 3x with this, and then solve for A and B. Right? Don't forget to remove the minus 2, right? That's how I got minus a half. Right? Remember the original identity is 2 of this, right? Minus 2 of this. So I'll move it here to get minus a half of cos A, cos B. All right, just try one from my right. So what do we know? We know that sine A plus sine B is equal to 2 sine A plus B on 2 cos A minus B on 2. Right? I don't want it 2 here, so I'll move it on the next side. So I'm rubbing it off, and I will end up with a half here. So it means that 8x has to be equal to this. A plus B on 2 is 8x. So A plus B is 16x, right? And then A minus B on 2 is 4x. So it means that A minus B is 8x. So I have equation 1 and I have equation 2. I am going to add them, 1 plus 2, right? So that will give me 2A is equal to 24x. So I got A to be 12x, and therefore B will be 4x. So it means that my final answer will be 1/2 sine A plus, open brackets, plus sine B. Let's try an identity using it, and then we will try to solve something using it. Try that, please. Right, so if you take the left-hand side, it will be 2 cos 3x plus x over 2 cos 3x minus x over 2 all over 2 sine 3x minus x over 2 cos, sorry, this will be plus, right? Cos 3x minus x over 2. Oh, yeah, it's minus, sorry. Here is minus. And here will be the plus, right? Sorry about that. This will cancel with this 2 will cancel with this. And you will get 3x minus x is 2x over 2. 2's will cancel. So you'll get cos x over sine x. Right? So this is cot x. Try this last one. Right, sine 4x minus sine 2x, we're doing the same thing again. 2 sine 4x minus 2x on 2 cos 4x plus 2x on 2. And the next one will be 2 cos 4x plus 2x on 2 cos 4x minus 2x on 2. Right, usual thing will happen. This will cancel off, and you'll be left with sine 2x on 2 all over cos 2x on 2. 2's will cancel, and you'll get sine x on cos x is equal to tan x. Right. While we're here, I want to talk about something, right? Suppose I ask you to solve sine 4x minus sine 2x is equal to, let's make it up something, let's say a half, right? I just give you a simplified version, right? We need to be able to break this down. So one of the things that we could do to solve something like this and get the angles is to use the identity that we use here. And we would have gotten 2 sine x cos 3x equal to a half. Actually, let's not make it a half. Let's make it 0, right? Because that's what you might actually see. What you can do there. In order for you to solve this, what you could do is, since it's a product equal to 0, you could say that 2 sine x is 0, solve that. Cos 3x is 0, solve that. So in order to solve something like this, what we could do is use the factor formula, get 2 factors, and make it equal to 0. You'll see why it's kind of called factor formula. You're getting 2 factors for this trig summation here. So if you see something like that, that's the way you will handle it, right? And then solve 2 sine x equal to 0, cos 3x equal to 0 between the given range. All right, so we're gonna try these tricks here. Before we start, I want to just do over one of these because I didn't do any like these, right? You all remember the triangle method? Okay, I'll do this one for you just to remind you, right? Watch this here. No calculator. Ignore this one for a little bit. Suppose I told you sine A is equal to half. How do you find cos A and tan A without going to the calculator? Let's start with the easier one, acute. Acute means it's here, first quadrant. And we know that sine, cos, and tan positive. Here's sine, here's tan, and here is cos. So how do we work this up? Well, you need to remember your little triangle. Here's A, right? Here's A, and this is opposite, this is hypotenuse. Opposite is 1, hypotenuse is 2. How do we get adjacent? 2 squared is equal to 1 squared plus adjacent squared, right? So you use Pythagoras theorem. Work it out, and you will get adjacent to be √3. So now that we know adjacent is √3, we can find cos. Cos is adjacent over hypotenuse, tan is opposite over adjacent. That's okay? And they all carry the same signs. Why? Because A is acute. What would have happened now, Adrian? In our example here, they say A is obtuse. Obtuse means first or second quadrant. Second. So it means that cos is what? Negative, and tan is negative. All right, so you're doing the same triangle method. Right, let's say here's A, opposite is 1, hypotenuse is 3. What is opposites? 2√3. But remember, A is obtuse, right? A is really obtuse. So what does that mean? It means that cosine A will be minus adjacent over hypotenuse, and tan will be minus opposite over adjacent. That's basically how you work it out, right? Sign is really important. Just do this profanaz it. So sometimes I like to just work with the right hand side a little bit, and then I will go back on the left side and do it, right? So I'm finding the LCM here, cos theta plus 1. Oh, well, that's it. That's all we have. That's all they have to offer. Right? But because the denominator looking like that, I've seen a little trick that you might need. You might need to multiply by this. And then you'll get 1 minus cos squared on top. And you'll get cos theta. All right, so left hand side, tan theta. There is no tan here, so I'll get it one time. That's sine theta on cos theta, multiply by sine theta on 1, all over 1 minus cos theta. The numerator is now sine squared theta, and I'm bringing up this 1 minus cos theta. Look, we get the answer already. Sine squared is 1 minus cos squared, all over cos theta by 1 minus cos theta. 1 minus cos squared is 1 minus cos by 1 plus cos. This will cancel with this, and you'll get 1 plus cos theta over cos theta. When you divide it up, that will give you 1 plus 1 over cos theta. That's it.